I've lost my way, won't you stay with me a while? I've lost my way, won't you stay with me a while? I've got a bad back, pins and needles in a stack. Won't you please tell the nurse medication makes it worse? Close the windows, shut the shades. You can try it, numb the pain. Don't want x-rays, just want you to hear me say, I've lost my way, won't you stay with me a while? I've lost my way, won't you stay with me a while? Mouth is dry, legs weak, IV's running like a creek. On a scale of 1 to 10, please don't ask me that again. Well, maybe St. Mary
All right, welcome everyone. Carrie, are you there?
I'm here.
Here
Can
you
you
are.
see me? Can you hear me?
Yes.
Okay, awesome. Thank you everybody for tuning in with us today. We have a really great afternoon in store for you. We're very unique, and we just have some good stuff on tap for you. So thanks for joining our Rare Storytellers program. My name is Carrie Hughes, and I'm the founder of Harmony for Hope. It is truly an honor to be here today with our hosts at the GSPMC. We're truly, truly grateful for our partnership. Thank you so much for having us, Chris and Kim and Dr. Yerudia and Dr. Basil. We're truly, truly honored to be here today. We also would like to give a special thanks to our event sponsor today, Execure. Without their help, we wouldn't be able to deliver our mission. And the mission of Harmony for Hope is to fuel scientific discoveries in rare disease, to educate community, and to uplift affected patients and their families with gifts of music. And I hope that that will all be reflected here today in our program. We achieve this goal by leveraging the power of music and combining that with storytelling. Since 2014, our musical ambassador and friend, Trapper Shep, of Milwaukee, has helped us unite people for the cause. Along the way, he has touched the hearts of so many with his songwriting, his musicianship, and his generosity of self, and really just his plain kindness. It's my honor to introduce to you now our very own rare disease ambassador, Trapper Shep.
Thank you, Carrie, for such a sweet setup, and good morning, I guess, good afternoon. Good morning for musicians like myself. It is pretty unique to be playing a show before noon. So yes, good morning, good afternoon. My name is Trapper Shep. I'm an ambassador for Harmony for Hope. And I'm going to be warming up today for Holly McNally, who will be sharing her story about raising her son, Harrison, with Kabuki Syndrome. Because this is an event that virtually takes place at MCW. I hope everyone likes me repping my MCW hoodie today. Because it is at MCW virtually, I'm going to start with this one called On Wisconsin, and it mentions Wauwatosa in it. Bob Dylan started this song when he was 20 years old in New York City, and 57 years went by, and I saw this article in Rolling Stone that said, lost Bob Dylan lyrics up for auction, $30,000. And I thought, well, I don't have that kind of money, but I will finish the song for Mr. Dylan. So I finished it, I put it out there on the World Wide Web. Dylan heard what I did with the song, and his lawyers called me up and said, how would you feel about publishing this with Bob Dylan? I said, I feel very good about that. So I'm gonna do a little bit of this song On Wisconsin, another one, and then I'm gonna turn it over to Holly. So here we go, On Wisconsin. Yeah, Wisconsin is the dearest state, guess you all know it well. I was in Wauwatosa, the truth I will tell. It's a milk and cheese and cream, yes, I've known it all my days. And I'm going to my hometown, I'm leaving right away. I'm headed to Wisconsin, 2,000 miles to go. Madison, Milwaukee, sets my heart aglow. I'm headed to that state and my heart's beating fast. And I'll jerk my banjo gently, twiddle my mustache on Wisconsin, on Wisconsin. It's calling me that way, on Wisconsin, on Wisconsin. I think I'm going to stay. Yes, there's thoughts I left there long ago. Ones are coming now, it seems. I'll tune my banjo in the hills, feast on milk and cream. stamp my foot through the grass, never know or care. Yes, my home's in Wauwatosa, and I'm going there on Wisconsin. On Wisconsin. It's calling me that way. On Wisconsin. On Wisconsin. I think I'm going to stay. Yes, I might as well stay. Yeah. So yeah, that was a little bit of On Wisconsin. And I just remembered in the original lyric sheet, it listed Wauwatosa as Wawa Toaster. So that was a running joke amongst us all that a Nobel Prize winner listed Wauwatosa as Wawa Toaster in his lyrics. But I digress. I'm going to do a brand new tune. This is called Paris Syndrome. And this is a real syndrome, actually, that happens to tourists who go to Paris and they feel massively let down by the City of Lights. And there's actually this Paris Syndrome hotline that was set up. Has anyone out there, as a show of hands, heard of Paris Syndrome before? You can Google it. It's not just, I'm not just making this up. It is a real disorder that happens to people. But anyway, I wrote this one when I was on tour in Paris a couple of years ago. So I'm going to do this one for you here off my new album, Paris Syndrome. There's fact, fiction, and fantasy. You and me, I wanted to believe there's maps, memories upon a wall, but see, it's him that's trying to call you. You're giving me Paris Syndrome. This is not what I expected. You're giving me Paris Syndrome. Disconnected, I am lost. Disconnected, I am lost. There's fact, fiction, and fantasy, the stuff of movies and make believe. Right when I needed you the most, you came like an angel and left like a ghost, yo. You're giving me Paris Syndrome. This is not what I expected. You're giving me Paris Syndrome. Disconnected, I am lost. Disconnected, I am lost. There's fact, fiction, and fantasy. Let down lovers not meant to be. She slept through pale afternoon. He drank that poison way too soon. You're giving me Paris Syndrome. This is not what I expected. You're giving me Paris Syndrome. Disconnected, I am lost. Disconnected, I am lost. Disconnected, and I am lost. So that's one called Paris Syndrome. Thank you for having me, Harmony for Hope and the Medical College of Wisconsin. I'm going to turn it over to Holly. She's going to talk about something much more serious than Paris Syndrome. It's Kabuki Syndrome. Thanks again, everybody, for having me. I'll see you on the back end of this terrific presentation today.
Thank you so much, Trapper. It's always fun when you're with us. So Trapper has a new album coming out in May. That song is on his new album. The album's called Mayday, comes out this May. So be sure to check that out at trappershep.com. And actually, before we move into Holly's story, I'd like to introduce Leo Kelly from Execure, who is our event sponsor today. Leo is the Senior Director of Research and Development Management at Execure. Leo?
Thanks so much, Karen. Can you hear me okay?
Yes.
All right, great. Well, hey, thanks so much, Trapper. Thank you so much. What a thrill, as always, to be joining today. I don't want to take too much time here. Trapper said it well. We have more important things to hear about, but I do want to touch on just a couple of points here. First, the importance of the work that you, Carrie, are doing, that everyone is doing here, and the excitement that we have for what we're doing here at Execure. So everyone on this call, if you've logged in today, you know better than most that rare diseases are very special, right? You don't have the luxury of going to the doctor's office and getting some medicine. We appreciate that here as well. And I want to take a moment to stress that the work you're doing is not merely admirable, it is actually completely necessary for drug development. I think that you are laying the foundation for how rare disease drug development should happen. And in my mind, your efforts are giving more than just hope. You are giving actual direction and path for the other 30 million Americans living with a rare disease. Before COVID, when we could all travel, one of the last conferences we attended was for the ataxias. And it had this fascinating mix of scientists and physicians, but also patients and families. And hearing the patient and family perspective was honestly some of the most useful intelligence, because it informed the medical community of what actually mattered. Achieving significance on a 6-minute walk test to gauge the success or failure of a clinical trial, it was just ridiculous. What mattered to patients were the various other quality of life improvements. And this voice meaningfully changed how subsequent drugs were assessed in the clinic. So, Carrie, we know that this is some of the most challenging type of work there is in the world, but we just want to let you know that we know that this truly matters. So thank you. Here at Execure, we are so thrilled to be in rare diseases, as honestly, we know this is where the patient need is greatest. Our most advanced compound is in phase 2 clinical trials for cancer. We've also put dermatology drugs into the clinic as well, but most recently we've announced our progress with our first neuro program in Friedreich's ataxia, and we also just announced that the next neuro indications we're going into are for Batten's disease, as well as severe pain. And we're very excited to be dedicating this exciting spherical nucleic acid technology platform for genetically driven diseases. And we've been growing a really exciting and terrific team here at a rapid pace. We've doubled in size over the last year with a team that's really committed to developing drugs for patients who need them most. We have a lot of scientists and other drug developers on the call. So while I have the mic, I am going to shamelessly, Carrie, put in a plug for Execure. And that is, if you are passionate about developing drugs for patients who need them most, if you are fiercely collaborative and you think you thrive in a fast-paced working environment, reach out to me. My contact info is in the calendar invite. With that, I have nothing else. Carrie, I'm going to hand it back over to you and say that we are just thrilled to be here. And as always, looking forward to getting inspired all over again to keep doing what we're doing.
Thank you so much, Leo. We really appreciate your sponsorship and your positivity and your alignment with our mission. We really appreciate that. I do think it's very important at this time to talk a little bit about rare disease and the prevalence. The rare disease patient journey is not straight and it's not narrow. It can take up to 2 to 3 misdiagnoses and 7 to 8 different doctors before an eventual diagnosis is reached. And that could take up to 5 years, maybe more. And many patients are left undiagnosed. So today there are over 350 million people worldwide collectively impacted by more than 7,000 rare diseases. diseases that have few, if any, treatment options and no cures. 50% of these people are children, and 35% of those children will not live to see their 5th birthday. 50% of these rare diseases do not have an organization that are representing their cause. And that's what drives Harmony for Hope. In 2020, Harmony for Hope contributed funding to translational research that's being conducted in Kabuki Syndrome here at the Genetic Sciences and Precision Medicine Center at Medical College of Wisconsin, under the leadership of Dr. Raul Urrutia and Dr. Donald Basil. In order to bring deeper meaning and expand our reach for this mission, we connected with Renee King, who is the founder of All Things Kabuki in Alaska. And Renee kindly introduced us to Holly McNally, which brings us to the second pillar of our mission, the first being music, the second being storytelling. Harmony for Hope is here today to share with you the patient journey, which is inspired by millions of stories like Holly's and her son Harrison's. These are stories of tremendous adversity, unstoppable resilience, and hope. Holly is joining us today from Michigan to share the story of her son Harrison, who was diagnosed with Kabuki Syndrome in 2018. In a recent interview, we asked Holly, what does rare mean to you? And here's what she told us. I think it's very touching. Before having a child with Kabuki, the word made me think unique, different, exceptional. I think those are words that describe Harrison so well. He's 1 in a million. He has overcome so much, but you would never know it. He lights up a room. He is always happy. He's never met a stranger, and he impacts every single person he meets by making them smile. There's just something about him that draws you to him and makes you go, wow, he's really special. So today it is truly my passion and my privilege to welcome rock star mom of Harrison, Holly McNally.
Thank you, Carrie.
Welcome.
Let me see if I can pull up these slides here. Give me 1 second. All right. So yes, thank you so much for letting me be the rare storyteller today and getting to share a little bit about our journey with Kabuki Syndrome. Like she said, my name is Holly McNally. This is my husband, Brandon, my daughter, Mallory, and then my son, Harrison. And Harrison is the one with Kabuki Syndrome. So Harrison was diagnosed with Kabuki at 3 months old. That was a relatively early diagnosis for Kabuki Syndrome and really just rare disease in general. Like Carrie said, it can sometimes take years for these kids to get their diagnosis. They kind of just run through the gamut of testing. They're misdiagnosed. It just takes a couple of tries. So we feel pretty lucky that Harrison received his diagnosis so early. So just kind of a little backstory of how we ended up with this. When I was pregnant with Harrison at 16 weeks, the ultrasound found that we had a 2-vessel cord. We were told that about 75% of the time, it means that, the child's normal, there's no issues. But 25% of the time, it usually indicated that the baby had some kind of syndrome or a heart defect. So at that time, we had some just basic genetic testing, and all of that came back normal. But then as my pregnancy went on, we found some more issues. So just having some overall growth issues. He was measuring small. His arms and legs were measuring short. And then at 28 weeks, we found out that there were some blood flow issues and just concerns for further heart defects. 29 weeks, they found a butterfly vertebrae at T10. And then 32 weeks, we found out that he had hydronephrosis of his right kidney. So it kind of just felt like one thing after another. At 36 weeks, my water broke and I went into labor. So he was born a little bit early, but otherwise it was a relatively uneventful delivery. So Harrison William McNally, he was born September 14th, 2018. And there is a picture of us. I got to hold him for what felt like 2.5 seconds before he got whisked off to the NICU. He was having a little bit of breathing issues and some low blood sugars. We already had those other concerns. So that was the plan all along, was to go to the NICU, but he just went a little quicker just because of those issues. So once he got to the NICU, the neonatologist noticed even more concerns. The hypoglycemia that I already talked about, and then he had a single palmar crease, cupped ears that were a little bit low set, small chin and jaw, depressed nose. He had a hole in his heart, so a PDA. And then he was also really, really struggling with eating. He had a high arch palate, which kind of contributed to that, but he was basically aspirating his milk. So everything, they called it frank aspiration. So basically everything that he was eating was going straight to his lungs instead of his stomach. So obviously that caused some respiratory issues. And so he was on oxygen for some time. And then some vision concerns with retinopathy of prematurity, obviously the kidney issues that we already talked about. And then he also had a hypospadias. And then he had a skeletal survey, which is basically x-rays of his whole body that showed numerous orthopedic issues. So Harrison is missing the middle portion of his right clavicle. He was born with hip dysplasia. So both of his hips were dislocated. The left one was so severe that it basically was out and up. They couldn't get it back into place. And then calcaneal valgus of his feet, so he has some feet deformities. When he was born, his feet were basically flexed backwards, touching his shin bones. And then the butterfly vertebrae that I already talked about. So obviously, all these concerns equaled more testing. So we had a chromosome test done at that point, and surprisingly, it came back normal. So all of these issues are kind of normal variants in the population. It might be normal for a kid to have hip dysplasia or hydronephrosis. One or even two of these things would be considered a normal variant, but to have so many of these issues, it was just concerning that there was just something else going on. So our neonatologist agreed. So when we were discharged from the NICU, we were referred to genetics. And genetics also agreed that there's just way too many variants here, that there had to be something at the root of all of this. So we had full genome or gene testing, myself, my husband, and Harrison. My husband was in the military at the time, so I don't know if that made it easier for us or if it was just the hospital we were at, but I hear very often that it's hard to get this test for other people with rare disease. So we were pretty blessed to be able to get that. So December 19th, 2018, I remember the room. I will never forget the date. We were supposed to take a while for this test to come back, and ours came back really quickly. So she called us in and said, I'm sure you assumed we found something on the test since we called you back in so quickly. And no, I don't know if we just were in denial because some of the other things had just been coming back normal, or we were just so overwhelmed with everything going on with Harrison that we just, I don't know, buried our head in the sand. But no, that's not what we thought when she called us in. So she told us Harrison was positive for KMT2D mutation on chromosome 12, which is autosomal dominant. It was a de novo mutation. So that means that Brandon and I, Harrison's parents, are not carriers. It was spontaneous. There's a less than 1% chance of this happening. So basically it was a fluke. Something happened, a mutation happened. We don't know why or when, but Harrison has Kabuki Syndrome. I don't really remember a lot of what she said after that, I started crying. There was a lot of emotions just flooding in. I think as a mom, you just automatically start kind of blaming yourself. Did I do something wrong? And then, there's also relief. There's relief that we had an answer, we had a diagnosis. And then it's also just devastating for your child that they now have this life-altering illness, and then on top of it, it's so rare. There isn't a lot of information out there, and there's no treatment. So it's just really a lot to kind of process and take in. I'm sure she told us about Kabuki syndrome. I don't remember all of that, but I know she just handed us this huge stack of papers with information and resources. I'm sure she knew that we were not going to take that in, and she came prepared with all of that. My husband and I were talking and just kind of talking about this day, and there's just one main thing that stands out that she said to us. She said, Kabuki syndrome does not define Harrison. Harrison defines Kabuki syndrome. And at the time, I was just like, okay, thanks, lady. But, it's so true. I mean, if you meet him, he's so unique and he's so amazing. And she was right. I mean, Harrison defines Kabuki syndrome. So at the time, it was maybe a little bit offensive, but I'm so glad she told us that, because that is just something that has really stuck with us over the last few years. So Kabuki syndrome, I heard the word Kabuki and I was like, well, that's a weird name. So it was originally called Kabuki makeup syndrome, and I'll kind of touch on that in a minute, but the gene was discovered in 2010, so it's relatively new. I mean, in the last decade or so. We know of 2 genes so far, KMT2D, which used to be MLL2. It's on chromosome 12, and that's what Harrison has. So 75% of the cases have this mutation. And then KDM6A, I think, is X-linked. It's 5% of the cases. So obviously that doesn't add up to 100%. The other cases are diagnosed clinically. So they might have had genetic testing done and they don't test for the gene, but a lot of geneticists believe that there are more genes out there. We haven't discovered it. So the other 20% are diagnosed clinically based on features. I am not a geneticist, but the way I understand how these kind of play out, these 2 genes play a role in organ development. So in utero, when the heart's being formed or when the kidneys are being formed, these genes play a role in that. And so when they start talking about adding and taking away proteins, that just goes way over my head. But that is why there are so many organs affected in Kabuki syndrome. We're not really sure why some are, more severe than others, but these genes play a role in organ development. So that's kind of the basis of that. So going back to Kabuki makeup syndrome. So in Japan, they used to do these plays, and they would paint their faces with makeup, and it was called Kabuki makeup, and it was just the look that they had. So when they were coming up with this name, the facial features of these kids, it reminded them of Kabuki makeup. So they really do. They have so many similar facial features. I can't tell you how many times I see another Kabuki kid. I'm like, oh my gosh, that looks like Harrison. Some of them look more like his sibling than his own sibling. They really resemble each other. So similar facial features, large eyes, long palpebral fissures, arched eyebrows, long thick eyelashes, depressed nasal tip, cleft lip and palate, high arched palate, dysmorphic ears, and abnormal dentition. Harrison pretty much has all of these. He has big, beautiful eyes with long eyelashes, probably once a week when we're out and about, maybe in the grocery store or whatever. Somebody always comments about his eyes. Oh my gosh, his eyes are so beautiful. He has really beautiful eyelashes. It's usually the ladies. They're very jealous about his eyelashes. But that's just part of his syndrome. So some other features of Kabuki syndrome, mild to moderate intellectual impairments, growth delays, low muscle tone, feeding difficulties, heart defects. I think the statistic is somewhere around 50-ish% have heart defects. We're involved in a lot of parent groups, and so a lot of these kids that do have the heart defects have had multiple surgeries by this age. So Harrison has not had to have surgery on his heart as of yet. We hope he doesn't need it. So we feel pretty lucky that his is relatively, mild. I already mentioned cleft palate, skeletal abnormalities, visual impairments, hearing impairments, communication delays, seizures, and autistic-like behaviors. So Harrison has all of these except for the couple that we don't know about yet, autistic-like behaviors, and obviously we don't know his intellectual abilities yet. He's only 2.5. So those are just those two things we're kind of just keeping on the radar, and only time will tell. So how has Kabuki affected Harrison? You know, we really try not to let it consume our lives, but unfortunately it does take up a big part of Harrison's life. He spent 28 days in the NICU, 4 months on oxygen, 7 months on home monitors, 18 weeks in a spica cast. So from like nipple line all the way down to his ankles, he was casted. Since he was 4 weeks old, he's either been in a hip brace or he's been in a cast. So at night he wears the hip brace when he sleeps. I honestly don't think that he would sleep well without it. He's just so used to it at this point. And then when he wakes up, we take the hip brace off and we put braces on his feet. So pretty much 24 hours a day, he is in some kind of orthopedic brace. And then 14 weeks in a helmet. He's had about 8 surgeries, procedures under anesthesia. One of those was a G-tube or a feeding tube. It was, you know, life-changing, but also life-saving for us. He still needs it a little bit for nutrition. He's eating pretty well at this point. We use it a lot for fluids just because of his kidney function. And, you know, when he's been sick, it's kept us out of the ER and it's kept us out of the hospital, just being able to give him nutrition or fluids through that. So we're grateful for that. 15 specialists, 2 of them are kind of on hold pause right now. We hope that we don't have to see them again, but we don't know at this point. And then he's been doing therapy about 4 times a week since he was 3 months old, whether that's OT, PT, speech, or feeding therapy, and then hundreds of appointments. When he was about 1 year old, I went back through my calendar and I counted out appointments. I don't know what came over me to do that. I was curious, and he had over 100 appointments. So when I say hundreds of appointments, I mean hundreds of appointments. And then he's had hundreds of therapy days as well. So kind of just worries as a parent. I mean, obviously we worry about medical issues. We don't know if he's going to need a kidney transplant. He doesn't have the best kidney function at this point, and we hope to, you know, we work hard trying to keep him hydrated and keeping it the best we can, but that's something that we may have to think about. We know that he needs more orthopedic surgeries. We don't know when that will be or the extent of those, but we know that those are in our future for his hips and maybe his feet. And then, you know, just like everyday things. We worry about, you know, will he be able to go to school? Will he have friends? Will he be able to have a job or live on his own? And I think the biggest concern we have is, what if something happens to Braden and I, you know, who's going to take care of him? I think those last things are all normal parent concerns, but they just become amplified when you have a kid with rare disease or medical issues. We really try to stay in the day-to-day and not dwell on the future. We really try to enjoy the moment. Sometimes that's easier said than done, but we also have to think about his future and try to be proactive in planning and just kind of keeping things on the radar and really making sure that nothing's falling through the cracks for him. You know, I feel like sometimes we get to a point where everything feels really good, where we're at a good place, and then something else happens. And so, you know, those are just kind of the things that are going through our head on a day-to-day basis. How has Kabuki affected our family? I think that the first thing that we go to is, how has it impacted our daughter, Mallory? She's been toted around to, I can't tell you how many appointments. I feel like we've lost some quality time with her. I mean, Harrison's care was just so time consuming in the beginning. And some days it still is. And so, you know, just really trying to find that balance and set aside time for her, some one-on-one time. you know, for myself, I struggle with that mom guilt, just making sure that she knows that she's important to me and that I love her and that I love her as much as Harrison. I feel like sometimes she gets a little overshadowed. And so that's hard. But on the positive thing, I feel like Mallory is so inclusive and she's so kind and she's so caring to other kids. She's in preschool right now, and her teacher always tells me she's always the helper. She's always looking to help other kids and help her teacher. And I think some of that comes with having a sibling with rare disease. We've had those conversations. I'm still trying to figure out how to have those conversations, but we've sat her down and talked to her and just said, you know, Harrison, he has Kabuki syndrome and he just needs a little more help than some of the other kids. So we need to be patient and we just need to be a helper. And so I think that it's, you know, striking home for her. I do see those characteristics in her. So that's a positive of that. I mean, all of this is tiring and it's stressful. I look back at maybe the first 6 months of his life, and I mean, it's all a blur. It literally was hour by hour, day to day. I honestly, I don't know how we made it through. I remember a lot of alarms going off, whether it was my phone alarm. I mean, I had alarms to feed him. I had alarms for medicine. I had alarms for therapies. I had alarms for appointments. Then we had oxygen alarms going off, just alarms. But it was just a lot. And I think, you know, all of that just, it changes you. It changes you as a person. It changes you as a family unit. I think overall, it's made us stronger as a family. You know, there's no way we could have gotten through that without relying on each other, and there's no way we can get through the future without relying on each other. I think it's taught us our strengths and helped us work on our weaknesses. We really do try to look through the positives. It's really easy with rare disease to kind of go down that road of negativity and just sadness, and it makes it hard. And so we do try to look towards the positives. I think that just makes life easier in general. I don't always do that. I catch myself going down that sadness path, but that's what we really try. We don't know why God gave us this journey. I mean, I don't know. I feel like overall Harrison has been a blessing. Obviously, we would take away the surgeries and the pain and the things that he's had to go through, but he's so happy. I mean, that's part of kids with Kabuki. They're just happy kids. He's been through so much. He just always has such a happy disposition about him. And if that doesn't teach you something, I don't know what will. I mean, that's what he has really taught me, is how can I have a bad attitude when he has been through just way too much for a 2.5-year-old, and yet he's so resilient and he never complains. I mean, you look at his pictures, he's always smiling. And I mean, yeah, I can't have a bad attitude. I have to look at him, and he really teaches you that. So where do we go from here? Unfortunately, there is no cure. There is no treatment for Kabuki syndrome. Really, we're just treating symptoms and problems at this point. So for us as a family, I mean, we obviously can't change rare in the sense of numbers, but we hope that we can change rare in the sense of when you hear the word Kabuki, that when you hear the word Kabuki syndrome, that you say, oh yeah, I've heard of that before. So just really trying to advocate for Harrison and other kids with Kabuki, just teaching anyone that we can, whether that's our doctors, our family, our friends, or even here, just trying to tell people about Kabuki syndrome. You know, in the beginning, we really didn't share our story. We kind of kept it private. I think we were just trying to process everything. And, you know, now it's our prayer that, you know, we can be a light, that maybe our story can help even just one person, then it's worth telling. So that is our story with Kabuki syndrome. And, you know, we're just going to keep telling our story and hopefully keep raising awareness for Kabuki syndrome. I'm going to plug allthingskabuki.org here. This has been just an amazing resource for our family, our friends, and even our doctors, clinicians. There's just lots of information on here for everybody. So if you're interested in learning more, I encourage you to check that out. And then obviously Harmony for Hope is amazing. If you want to check them out on social media, there's some links there. But thank you, Carrie. Thank you so much for letting us tell our story and teaching you guys a little bit about Kabuki Syndrome.
Holly, thank you. You did great. I know it's very hard to do. I'm sure it's very emotional. And I want to thank you from the bottom of my heart for being a part of our Rare Storytellers program, because I do think, and I do agree with you, that these stories need to be told and heard. And if we can raise awareness and make one more person aware of Kabuki Syndrome, then I think we've done our job. So thank you for being a part of our mission in that way. We're really grateful. And now it's my honor, really my distinct honor, to introduce to you today Dr. Raul Urrutia and Dr. Donald Basil. Dr. Urrutia is a professor in the Department of Surgery, director of the Genomic Sciences and Precision Medicine Center, and a member of MCW Multidisciplinary Team Science in Rare and Undiagnosed Diseases. He has a background in physics, mathematics, and computational science that has been fundamental in designing, implementing, and evaluating databases and data mining tools for medical records, as well as genomic sciences and precision medicine. His appreciation for these disciplines originates from pursuing research in human diseases. Dr. Urrutia has dedicated his career to understanding the relationship between genes and diseases. With his team, he develops methods for better interpreting alterations of rare disease-causing genes using an approach that involves 3D reconstruction of the affected genes and its examination with advanced scientific methodologies. Dr. Donald Basil is the medical director for the Clinical Genetics Services for Children's Wisconsin. He is an associate professor at the Medical College of Wisconsin and chief of the Division of Genetics within the Department of Pediatrics. He is the associate director of the Rare and Undiagnosed Disease Program within the Genomic Sciences and Precision Medicine Center. And additionally, he is the director of the Medical Genetics Fellowship Program. He completed his medical training in South Africa, moved to America in 2001, where he worked as a research fellow with a focus on connective tissue disorders. He repeated his genetic and pediatric training in Portland, Oregon, prior to joining MCW in 2010. Please welcome Drs. Raul Urrutia and Dr. Donald Basil.
Thank you for that very kind introduction.
Thank you very much for that kind introduction, Carrie. And thank you very much. It was a wonderful, wonderful introduction, wonderful storytelling, beautiful music. Trapper, I'm gonna get jumping on that news release you're gonna send. So it's a pleasure to be here today. Thank you.
All right. And I think I go first. I'm just waiting for Chris to set up the slides. We'll give him a second. While we're waiting for Chris, I just wanted to say, Holly, thank you very much for sharing your story. I can give you a little insight as to why Michigan is so good with testing, and that's because they're probably one of the leaders in precision medicine in terms of state-backed programs. And they've jumped headfirst into the idea of genomic sequencing. So it's much easier for people in Michigan to actually get that type of sequencing than it is for most other states. We've approached it from a slightly different way. And we've bundled a whole lot of diseases together so that we can still use insurance companies and target a single code, but also get fairly comprehensive off sequencing through that process. But it's great that more and more groups are doing broad sequencing so that you can achieve diagnoses at an earlier stage and get the appropriate help that you need. It sort of reminded me what Renee said during our meet and greet earlier, where it took them such a long time to get well, actually the gene wasn't discovered. And a sort of an inside joke in the genetics community, if you didn't know what the syndrome was, you used to actually just, well, people would joke that you'd label it Kabuki Syndrome because nobody could prove you wrong. The presentation I'll give you today will give you a sense of why there's so much overlap between so many different syndromes. So I'm not sure who's controlling the slides. Is that you, Chris? All right. I think this is you, Raul. Why don't you present your group?
No, there's been a mistake. This has to be at the beginning, but at the beginning of my presentation, or
Gotcha.
It was put at the beginning here for some reason. So I apologize. This is part of the team that is going to come later, but maybe you can go ahead and present and then we will go. Thank you. Sorry.
Sounds good. Can we jump to the next slide? Perfect. So Holly gave a really wonderful introduction into Kabuki syndrome and some of the clinical manifestations. What I'm going to focus on today is a little bit of the science behind Kabuki syndrome and how we think about Kabuki syndrome. And we know that Kabuki syndrome is an autosomal dominant disorder. In other words, you just need one of the two gene copies that you have to be impacted in order to present with the condition. It's usually caused by a change which causes loss of function of either one of the following genes. The lysine-specific methyltransferase 2D. This is the wrong slideshow. Chris, I don't know what's happened, but a lot of the slides had the wrong
Okay, let me.
Positioning. Because I modified it and then resaved it, so it should have saved to the online version that you were using. Anyway,
let me go back 1 second then.
No, sorry.
I have
technology across the web.
I apologize. Give me 1 moment. Let's try.
Is this the same link that Aaron used earlier on? Because that's the one I modified.
Yeah, I went straight from the link. Let me just click the link again. No, this was the last one I have.
That's okay. We'll make it work.
Okay. All right, well then let me just get back into the screen share here. Okay.
Yeah, we'll jump over in here. So the two genes being the KMT2D and the KDM6A, which are, and the important part here is the name of the gene. So it's a methyltransferase and a lysine-specific deaminase 6A. And the reason why that's so important will become more apparent. What both of these genes do is that they change the methylation status of something called the histone 3. And what that does is it facilitates the opening of chromatin. Now I'm saying these things as though you fully understand what's going on, but the next slide will make perfect sense. And what those two functions do is that they control gene expression. And if you basically lose the ability of one of these genes, you impact the ability of the genes to function with normal gene expression. So if we can pop to the next slide. So what I've shown you here is a picture of the sort of the complexity of how genetic material is contained within each and every single cell. So what we commonly understand is that every cell has chromosomes, and those chromosomes contain the genetic material. And we generally think of that genetic material as being a very important aspect of just the code itself. So that right at the bottom of that slide, you see the helix, which is winding round. That's representing the code itself. But what people don't really focus on is how do we use this code and how does it become functional? And that's really where Kabuki Syndrome has opened our eyes in terms of understanding what's going on. So that double helix, in order to be able to be folded into such a compact structure like the chromosome, needs to be complexed. In other words, it's wound around these things called histones. And these histones are made up of different protein subunits. And if you look at the picture on the right-hand side, those histone subunits have these little tags on them. And if you remember from what I said with the KMT2D and the 6A, they impact histone 3. So the key here is that it's changing how the protein is activated within the complex of this dense chromatin structure. So the title of this slide, Holding It All Together, Linking Syndromes Together, is exactly that. And that's why you see so much variability. We now have a much better understanding of the importance of chromatin and its three-dimensional structure, which is really a lot of the work that Dr. Urrutia has been doing, is looking at how those conformational changes impact gene expression and how important it is to our understanding of gene expression and disease process. This is a very important mechanism in cancer genetics. And I don't want you to confuse saying that these genes primarily cause cancer, because we know that as an autosomal dominant disorder, it causes the syndrome that we're familiar with. But when this happens in isolation in cells and cell gene expression becomes dysregulated, that's where other things can occur. So if we can go to the next slide. Now this is a very busy slide, but the reason I put this here is when you have chromatin opened, it's the opening that allows other things to come in and help that gene expression. And this SWI-SNF complex is really important when we think about epigenetics, which is a term we use to define that things external of the primary code, so almost those environmental things or those extra genetic things that still control gene expression. So this SWI-SNF complex is critically important with interacting with the elements that control chromatin structure. And that's why we see this very broad overlap between all of these syndromes. And if we go to the next slide. All right, this is, well, there you go, it's going to work. So maybe not. What these genes do, once your chromatin has been opened up and these other proteins are allowed to come in and control what happens to that gene expression, the area that we're particularly interested in is what happens to the neural tissue. So neural tissue specification is critically important, controlled by these different genetic processes. Neural stem cell proliferation and neurogenesis, which really drives that whole embryological process of neurogenesis, but also controls adult neurogenesis, so how our neurons connect with one another. If we click again. Why don't we just click a few times into one? I think that's the last one. So genesis of neuronal subtypes orchestrates neuronal migration, maturation, and how they interconnect so that they can form this very complex neural network. And then gliogenesis, which are the supporting cells which actually support the structure of the neural tissue, how they are formed and specialized so that they can help the nerves function themselves. So you can see this is a really important control mechanism for neuronal development. But in the same way, all other organ systems are impacted in a similar way. So it really has to do with controlling a lot of genes in the early embryonic phase, but then continuing to control genes that are critically important at certain points of our lives. Can we go to the next slide? Oh, and then finally the function of memory and learning. All right, next slide. So this is just a sort of a pictorial way to try and encompass everything that I've been trying to say in terms of how complex it really is in terms of changing the methylation status on the chromatin, which then allows additional genes to be expressed and different pathways to be controlled. And I'm not going to go into the details of all of these slides, but just from a cartoon perspective, just to see how complex it is and how it all interrelates to one another, which is why we end up with syndromes that are not just a single heart defect, for example. You can get a whole lot of things like Harrison has, where you have kidneys and heart and palate and all tying together in a single individual. So if we go to the next slide. So this slide really pulls in a lot of those syndromes that I've been talking about, sort of the crossover. So linking all of these different disorders that have different names. And we see Kabuki syndrome here front and center. And we see that I've highlighted that as being a methyltransferase and demethylase. And a lot of these other disorders you can see have similar protein links to them. So Wiedemann Steiner, for example, has histone methyltransferase. It's True's Alu-Klein, which is a very rare disorder. It doesn't have a protein function itself, but it's an RNA binding protein that then interferes with chromatin remodeling. So you end up with a similar endpoint as you would if you just impacted chromatin remodeling to start with. And really, this is just the tip of the iceberg. This is just us beginning to understand how these disorders all correlate to one another. And it sort of speaks back to a comment I made earlier on about testing. If we suspect a child has Kabuki syndrome, I never just do a targeted test for Kabuki syndrome. I test for all of these genes because there is such significant overlap between them all that if I didn't test them, I'd then have to be going back to each one of these disorders and testing subsequent genes if the testing was negative. So ideal would obviously be to do genomic sequencing in everybody, but we can't do that. So as a second best, we try and cluster all of these groups of disorders together so that we're looking at what disorders can impact chromatin structure. And that's where this name comes from, these chromatinopathies. So we're beginning to think more and more of Kabuki syndrome as part of this chromatinopathy spectrum disorder, but obviously being a disorder in its own right. If we can have the next slide. And this really, you weren't supposed to see the second picture, but basically what this slide shows is that the facial phenotype of these, if you can just click that front-facing thing should disappear. Chris, if you can just click once. There you go. So what we use, one of the tools we use in the clinical realm when we're doing medical genetics is we have facial recognition software. The ability of dysmorphologists has really morphed considerably over the years. More and more syndromes are being identified. There's more overlap between these different subtle syndromes. And some things that computer matrices can differentiate significantly surpass any dysmorphologist's ability to recognize. And what this paper does really is looking at the predicted craniofacial gestalt from what we would expect to see in these chromatin-related disorders. How much does it overlap and segregate? And this diagram here shows what the predicted sort of what would the word be? Sort of a conform picture versus the actual image of the patient that was being analyzed. And you can see there's quite a lot of overlap between the craniofacial phenotype that we see in amongst all of these chromatinopathies as a whole. If we go to the next slide, right, just click it several times because I'm not sure what the, whoops, up, perfect. So this slide basically shows the overlapping phenotypes in all of these chromatinopathies. So we know that there's a very broad group of disorders that are what we call genetically heterogeneous. In other words, they're different, but they overlap with a common pathway. They're all involved in chromatin remodeling. And the genes basically encode for enzymes for the vast majority of time that impact those histones, those little proteins around which the DNA is wrapped around to create a structure which can then become a tertiary compact structure. So that chromatin modification. And those can be histone acetylases, deacetylases, methyltransferases, demethylases, as we have in Kabuki syndrome, kinases and phosphatases. And these are just proteins that act as enzymes that can impact the little tags on those histone proteins. And what we see is we see an overlap between the facial dysmorphisms that we see. Dysmorphism just really refers to a variation from what we anticipate as norm. And that can be, people talk about dysmorphic MRIs, but in the context of genetics, when we typically think of dysmorphisms, we think of embryological development and the variation from normal development. From an eye perspective, we commonly see hypertelorism, in other words, widely spaced eyes, blepharophimosis, slightly shortened, well, closed eyes, blepharoptosis, which is sort of the large appearance of the eye, the abnormal ocular conformation, noses tend to be broad, sometimes a sort of an overhanging tip of the nose, and the way that's referred to as a beaked nose. The nose can be short. The ali nasi, which are the sort of the nasal passages, can be anteverted, in other words, slightly upturned. One of the classic features that I tend to see is a very thin upper lip with a very full lower lip. And that's one of the primary features of many of the chromatin-related disorders. But obviously there can be some variability. Next slide, please. Perfect. And this is where the hope lies. One of the things that we know that, especially with epigenetic disorders, is the problem is with reading and having access to the appropriate point of the chromatin. So if we know that the loss of function of these proteins causes the chromatin not to open normally and not allow normal gene expression to occur, there are other drugs out there which we know can impact the epigenetic tags. And this is where some of the work that Lee's doing in terms of looking at drugs that can be repurposed from common disorders into rare disorders could potentially open avenues for people to start doing additional research. Now, this was all done in mouse models, but it provides a basis for us to think about, could there be a hope in the future where we could impact the outcomes of children with Kabuki syndrome by looking at changing their methylation status and actually changing the ability of the body to be able to read the appropriate genes it needs to read at the right time. Obviously, this needs a lot more research because randomly opening genes for expression can have what we call off-target effects. So you don't want to create more problems than you're trying to fix. But I think in the appropriate study environment, this allows us to consider the future for Kabuki treatment. And last slide, please. Right. This idea of chromatin, although we're dealing with rare disease at the moment, one of the things that comes out of rare disease is an understanding and a recognition of how that three-dimensional architecture of chromatin structure could impact many other diseases, many common diseases. And this is a paper that was written a couple of years ago, really looking at that actual context of how does chromatin ultrastructure impact normal disease? And is there a way that we might be able to impact these epigenetic tags to treat more common disease? And this is all being discovered through the study of rare disease. And that's all I have for you. Thank you.
Thank you, Donald, for such a good introduction. First of all, I am extremely humbled and thankful for this invitation. Obviously, it was magnificent to see, to just actually not only to hear the excitement of the music, but also to hear the story. I think that the stories like yours are truly will keep us here, and it will continue keeping us here. I will not spend a large amount of time talking about epigenomic, but I will tell you that I have dedicated my life to it. I opened the first laboratory that existed at the Mayo Clinic 31 years ago on the study of epigenomic, which is the disease or this series of diseases that Donald has been talking about. And at the beginning, I have to tell you that we began with normal development, and then we continued studying cancer. And then as we were working with genes, then other diseases showed up. And today, 30 years later, we're commonly called from people all across the world for genes that we have identified before, many years before that the disease was identified. The reason I bring up into cancer is just like to echo Dr. Basil, is that obviously this disease does not develop cancer. However, the genes, when they're broken, also alter, not in the germline, not in the sperm or in the egg, but it is actually broken in the tissues, is cause of very severe cancer. And so that is good news, because we also work here at the center with the pharmaceutical industry, and there are a large amount of drugs against epigenomic therapeutics that are coming into the pipeline. And in fact, they're being tested here at GSPMC. For instance, some drugs that are working in cancer can be used for Prader-Willi syndrome and so on and so forth. So there is a light that is coming that I think we have to be very hopeful. So if I can go to the next one, please. I am the director of the Genomic Science and Precision Medicine Center, which has been always dedicated to saving lives and improve the wellness of individuals and family affected by rare diseases. And now we want a large campaign to actually be part of the families that you are inviting us. Next one, please. At the Genomic Science and Precision Medicine, we of course have the most advanced technology that exists today. What you are seeing in the omics area is you are seeing the fastest sequencers that exist in the regions, and these sequencers can sequence an individual very fast. And what you see on the right is, or on the other side, is supercomputers that we have so that we can process the data. And it is by building a data of the normal person or the regular variation, the most observed variation and the most rare variation, that we can make the maps and put it together and then go into diagnostic and therapeutics. Now, GSPMC does not only work regionally, we have a national and an international network that is growing and is in rare diseases. I am a board member of the rare diseases in Italy, and also in Spain and in France. And we are now just linked with Turkey, and we are receiving cases from Turkey. Here we work with the Mayo Clinic and with the National Institute of Health, and of course, the center here with Donald Basil is our champion in rare diseases. The next one, please. Of course, what we want today is we want to send a clear message. Clear, straightforward, without confusion, without lingo. We want to partner.
and we're partnering with Harmony for Hope, and it's been a just tremendous gift in our life that Carrie and now Phil are part of our family, and we're part of theirs. And of course, we want to be part of your Kabuki family. You let us, we will be very humble. Go ahead, please. So how I want to talk to you about this, and I will use a disclaimer. This case that I will introduce today, and I will call her Melinda just to protect her identity. It was an inspirational case, and so I'm going, it's a personal story as well, okay? And this is an individual in which we use all this powerful technology, right? And then we made the map, and then we find the individuals, and then we potentially could match it to a therapy. Now, what is the strength of this sometimes? If we can do this, and now this is a person who has a particular disease that had it, or a particular variation that could find a therapy. And so the strength is that we can do it here at MCW. I was doing it for several years at the Mayo Clinic, but we are here. And in fact, something that I found here is this tremendous, unbelievable richness of partners like Dr. Basil in the clinical arena, which are making our work in genomics much easier every day. The weakness is that we cannot save as many people as we could save. Now, if you're ready, we'll start with the story, because here is where we come. This is the cross of the problem. We cannot save as many people as we could if we were to incorporate advanced interpretation for undiagnosed and rare diseases. And that has been the work of our group. So the next one, please. So what I want to show you, this is very simple. So what we're going to do is, I'm going to show you today something that means a before and an after. In other words, there are moments of before and after in science. So here is one of the classical examples that all of us know, right? There was a wall of confusion at some point, but that came after, for many, many years, the dominant model of our universe had the Earth at the center. Until we went to the sun, to the heliocentric or sun-centric view of the universe, which is the one that we have before. We call these fractures. And it's not that we can do this very slowly, but just one small little step. We have to make big leap of faith in the knowledge, in empty knowledge, in order, it's a vision. Okay, and what we're going to show you today is a vision that took roots and is working well. So the next one, please. So this is how everybody has been diagnosed so far. This is how we diagnose today, right? So you have the DNA on the left, and that's a code TCGA. But what is the DNA? Let's ask. I mean, it's very important, right? But it's like the machine language of your computers. It's 1, 0, 1. 0, 0, 0, 1, 1, 0, right? It's TCGA, ATCG. And then we have the Rosetta Stone in the middle, okay? Because you see, if we put 3 of those letters, right? We can make 1 letter of the pieces that are gonna make the gene products, which many times are called proteins and also RNA. But in this case, I will be talking into proteins. So the concept here is that we go to translate the sequence of the DNA using the Rosetta Stone into the protein, and then we interpret if that variation will create a problem or not. Well, it turns out that today, if the variation has been identified, I can call it, and I can make the diagnosis. But if the variation has not been identified, it's called of uncertain significance, as it is like this, and there is a large amount of individuals that remain, most of the individual in a diagnostic odyssey remains in the uncertain category. And that is a problem because we cannot improve diagnosis, prognosis of treatment events. So let's move ahead, please. So this is what we call the other one, the genomic in 3D. Here comes the fracture though. On the left, you have a condor, I was born at the foothill of the Andes, at the foothill of the largest peak outside of Himalaya called Aconcagua. And there is where this animal inhabit. And here you have a picture in 2D, right? Well, what about if I tell you that suddenly we're going to expand the vision, all right? And we are going to have this vision of translation from TCGA, from the DNA to the gene product to the protein that we were doing in 2D, like a picture. We will do it like a motion movie. And we were able to capture more information, opening the eyes to genomic interpretation with a new 3D view, as we call it, the 3Genomics project. Go ahead, please. So I must remember, though, that what we were using was knowledge of the DNA alone. And you know that the DNA does RNA, but ultimately, many times, like in Kabuki, it has to do the protein, right? Well, just having the 1, 2, and zeros of the machine, the TCGA, sometimes doesn't help much in mechanisms. We have also started with transcription, so we're reading this. But today, what I'm going to tell you is about the proteins. So we are getting more information by studying the gene product than the gene in itself. You understand? So we call our program Beyond the DNA Sequence, okay? Because we focus on gaining information, but on the gene product, gathering information from the gene product. The next one, please. So how does it work? It works like this. We're going to move from 2D, which is that representation of letters all together in a piece of paper without height, without depth, just in 2D. And we're going to see that the genome is like that. It's actually the instruction. It's almost like a blueprint. But if you want to make that gene, it comes like this. It has a structure. It has depth. You cannot say it. We can, because we have powerful machine that can image them, and I'm going to show them in a few minutes. So they have this shape. Not only that, they have dynamics and motion. Can you see? So that the normal gene produces a product that makes this nano machine. So the genes are here to encode for the nano machine or microscopic machines that work like the tools, the screwdrivers, the Allen wrench, and every single thing we need in the cells of the organism to give rise to life. The next one, please. So this is just to give you an example. This is an early discovery from my postdoctoral, if you can play, from my postdoc. I can't play it. Can you play it for me? Yes, so what you can see is a discovery that I published when I was a postdoc. You see this molecule that is walking, right? That is a gene product. That is not the gene, that is the gene product. Again, that is carrying organelles along, is carrying the vesicles with a neurotransmitter in your head. Again, please. That neurotransmitter that makes you move or think. And you see, it's a molecular motor and it works. And if the step is larger or smaller or shorter, then we will have problems. Now, what we are doing right now is, again, is translated the gene into their three-dimensional and dynamic gene products to gather more information. Next one, please. So this is another that you can play, Chris. This is a molecular motor at the atomic resolution level. This is actually a gene that is an epigenomic regulator, just like Dr. Vassell talked about it. And what you can see is that the gene product, green and in red, right, it moves. And it will move always exactly because at the bottom of our life, there is also something similar to mechanics, okay? And we call it the molecular mechanics and the molecular dynamics. Now, we cannot get this 3D interpretation from just the TCGA. And this has been the work that during the last 10 years we initiated at the Mayo Clinic. Then we came here and we have joined a fantastic group that I hope I can show you image of them to study this amazing nanomachine and see when are they broken. Go ahead, please. So recently, we are very grateful to Harmony for Hope for funding the first Kabuki syndrome, which is study KDM6A variants. I have to tell you that we are also studying the other variants, and we're going to study more Kabuki. We are dedicating ourselves to the study of chromatinopathies. So today, however, I chose you to show you this because it's a celebration. It's the first paper that we published together with Harmony for Hope, and we are extremely grateful for your support. Now, what I'm showing you on the right is the molecule. It's the 3D structure, but also with movement. If you can play it, you see? I mean, that is the product of the gene. You cannot get all that information from just the genome sequencer. So we are working with these reconstructions in 3Ds of the nanomachines that are being made by these genes. And look what is going to happen in the next slide. I'm going to show you an example that is clearly, next slide, please. On the left, you have the DNA paradigm, right? The TCGA translation flat. But on the right, we really have the structure of the nanomachine. And in circle, I have put the normal and a Kabuki causing variant at the bottom, okay? And in circle, you can see a green region because on the right, you're gonna see how this nanomachine moves. And on the top is gonna be the normal, on the bottom is gonna be the abnormal, and you are going to see the problem that this variant has in the movement. So go with the top, the normal first, and you see the green area in the normal, which is the top, is moving. If it was, okay, do you see how it moves? It should move a little bit faster, but today we are a little bit slow, okay? But if you go to the bottom variant, for instance, okay, that part is almost like it has lost the connection, right? So that's what it's showing you. One is that it's abnormal. The second is giving you the mechanism. And third, it gives you the structure and the abnormal structure on which it can be used to develop drugs. And we are working here with the group of drug development, our partners from the structural chemical biology program that do drug screening and drug development, working together in this area as well. Go ahead, please. So we went from 1 patient to begin with, and then we were from 11 patients, and now I'm gonna show you 197 different variations. So we have analyzed 197 mutations that occurs in cancer. Now, what happens with this is that both MLL and KDM, although they do not give cancer in Kabuki syndrome, they do, when they get broken, give rise to very severe pancreatic cancer, and one that it has a preference for female, and it's very devastating. And KDM6 is also, these are mutations in female affected with pancreatic cancer, but we expect that as we continue going, this variation will also be seen in Kabuki syndrome. So we are studying them already in anticipation. So if some kid shows up and says, what does this mutation mean? We have information now to be able to provide them with what it could be or how it could be working. The next one, Chris, please. So here is where we are crossing a new frontier in science, because we went from the Earth-centric view of the universe, basically, to the sun-centric view of the universe. We went from the 2D to the 3D. 100% of the molecular diagnostics today are being made by just looking at the DNA sequence and the protein into just the sequence. And what you're gonna see in pioneering by GSPMC and the networks of collaborators is that the 3D investigations of the gene products are just soon going to find their way in the guidelines for the community, for use in the community of rare diseases. It is my ultimate goal, and it will be made, and we are on the way there. The next one, then, we did, no, go, if you come back before we more, is that we have, this is so revolutionary that from a picture, we went to a movie. So we have created a new lens. It was like we didn't have eyes, but now we can see. Next one, please. Together we can go faster, further, and better. And so we put the scientific invention, but we also want to work with you in the community because we are part of it. And we are very grateful that you let us be part of it today. The next one, please. Thank you. Somehow I lost the picture, or was presented at the beginning, the picture of the team, because as you know very well, this is not made possible without a very large team of individuals. And so I want to thank many of them, and particularly Dr. Vassell, Dr. Volkman, Dr. Zimmerman, Dr. Smith, Dr. Mathis, and Dr. Lomberg, who have participated in these investigations, and all the postdoc students and partners that made this possible. Thank you so much.
Thank you so much, Dr. Urrutia and Dr. Basil. I know there's going to be tons of questions, and so we do want to move right into our Q&A, which is going to be conducted by Harmony for Hope scientific advisor, Dr. Phil Chaikin. Phil joined the Harmony for Hope team in 2019, and Dr. Chaikin is an internationally recognized expert in global drug development and regulatory strategy. He spent close to 30 years in pharma R&D, and he currently maintains an active consulting practice and has supported many pharmaceutical and biotech companies. Dr. Chaikin holds a bachelor's and doctor of pharmacy degree from the University of Maryland School of Pharmacy, and he completed his fellowship in clinical pharmacology at the University of Maryland Hospital in Baltimore, Maryland. He also holds an MD degree from Rutgers University, New Jersey Medical School. He performed his internal medicine training at Robert Wood Johnson University Hospital in New Brunswick, New Jersey. Phil is live with us today to facilitate our Q&A from Sarasota, Florida. So I'll pass it over to Phil.
Well, thanks very much, Carrie. Can you hear me okay?
Yes, sir.
It's a long distance from the Gulf Coast of Florida. Anyway, before we get into the Q&A, I know we're running a little bit late, but there's several things that I wanted to talk about. First, to Dr. Leo Kelly and the management team at Execure for sponsoring today's event. We truly appreciate the support of Execure. And a heartfelt thanks to Holly McNally for taking us on her very personal journey with Harrison. It's critical that all of us health professionals who care for rare disease patients and conduct medical research on these diseases listen and learn from our patients and their caregivers. So thanks so much for spending time with us today, Holly. And many thanks to Drs. Urrutia and Basil for an excellent discussion on the research that they're doing on this disease and chromatinopathies in general. It's truly a pleasure for Harmony for Hope to be in a partnership with MCW and the Division of Genomic Sciences and Precision Medicine. So before I go into the chat room, I see we have about a dozen questions or comments. I have two quick questions I'd like to pose. And the first is for Holly. Given the multifactorial parameters in the pathophysiology of Kabuki Syndrome. Did you find that Harrison's physicians worked as a team to coordinate the most optimal care for him? I mean, it would seem to me that a multidisciplinary team-based approach would be needed to optimize his care.
So my husband, like I said, was military, so we've kind of moved around a lot in the last few years, so that hasn't helped that aspect of things. But we do go to Boston Children's that has a Kabuki clinic there. So that has been very helpful in helping to coordinate things. Really just, you know, they seem to be on top of what to look for next. So that has been a huge help for us, seeing the specialist there and then taking that information back to our clinical staff back home.
Great, thanks. So this is for Doctors Basil and Rudia. You guys gave an excellent presentation today. Given all the work that's being done in genomics and proteomics and the epigenetics of Kabuki syndrome, what have we learned regarding identification of new drug targets to modify the disease? I am aware of the use of histone deacetylase inhibitors and histone demethylase inhibitors evaluated in mouse models of Kabuki syndrome, which appear to increase neurogenesis in the hippocampus and normalize some learning and memory deficits. I don't know at the end of the day, as a drug developer, whether a small molecule approach will have a great probability of success to treat this disease, but we're still in the preclinical stage with HDAC and histone demethylase inhibitors from my reading of the literature. But is there a role for genetic editing or RNA interference to either remove or silence the loss of function mutations in the two respective genes and increase expression of the wild type allele to restore functional activity of the gene? So we've got the traditional small molecule approach, which is being evaluated in murine animal models. But the broader picture, does gene editing or RNA interference have a role to play in this disease?
Well, when it comes to the terms of therapeutics, I'm going to let, I will talk from the point of view of discovery and the center and investigations, and then I will let Dr. Basil to expand in the use and clinical applications and the potential pitfall and problems. I think that the small drug is still an attractive proposition. I think that we start with this problem, but these are nano machine or microscopic machines that regulate gene expression. So they're going to do it all through the life of the individual. So we don't know at this moment. Of course, it's very premature because you said it's in the preclinical models. If one was going to use them at some point, would they be able to manage progressions, let's say, or improve quality of life? That's one of the possibilities, though, as you said, that is very early on, and some of those inhibitors are being tried even here. In terms of gene editing, and again, I will allow, I look forward to hear Don's comment, but in terms of gene editing, of course, I mean, this is a moving target. I mean, Europe is more advanced in looking at the application of gene targeting to some rare diseases. I think there's been a remarkable advance, not only in gene editing, as a matter of fact. There's been many other vectors that many years ago, we didn't think they were going to work. So I think that in order to use gene editing, it could be a possibility in the future. Obviously, currently, as a scientist, all our investigations that obviously it's unethical, and we do not promote investigations in human beings, or at least personally or institutionally, on gene editing on human beings.
Perfect. I think that's, can you hear me?
Yes.
Yeah.
Perfect. Phil, I think it's a great question. The I think the bigger hope and the sort of the future is really the work that Raul's doing in modeling the three-dimensional changes that can occur. So if you can basically have a pathogenic example of what happens with that gene mutation, and then you can then see what types of impacts changing the epigenetic environment through drugs could have on a model system, is going to be our best bet in terms of trying to find something that would be effective, at least in the sort of early preliminary screening phase for looking at molecules. To address your question specifically about using some genetic mechanism to knock down the loss of function, most of the, actually, I think all of the genetic variants in Kabuki syndrome are loss of function. So the actual change causes that particular protein not to be present and not to function at all. So using the technologies where you actually knock out gene function, you're essentially just doing what the genetic change has done already. So you won't be able to fix it. That mechanism is really good for something that we call dominant negative effects, where a remnant or a partial protein stays behind, and that causes the disease itself. And that's where those types of gene editing and RNA silencing technologies can be really effective. So what we really want to do is, how can we switch that gene back on so that it is effective? As Holly and all of the people who are impacted by Kabuki syndrome can tell you, that starts off in pregnancy. So you'd have to know preemptively that you were going to have a child with this particular condition, and start gene editing the embryo.
Right.
So that's the point where you could potentially fix an embryo. At this point, we're using pre-implantation genetic diagnosis to not implant affected embryos. But I guess the time will come where we can impact genetic change early enough if it's identified during a state of pregnancy. That's probably not in my lifetime. I'm not imagining.
Years down the road yet.
Yep.
I feel
Great,
just
thank
very briefly, just to tell you that what Donald was highlighting, there is a case today of a disease that is less rare than they used to be during my time, right? The CFTR. And you have what we are doing, the structural approach, have allowed pharma to develop compound specific for certain variants, not for all the variants, for certain variants, including the most common, right? And they're being in trial for CFTR, right? And so I think that the identification of genomic variation in 3D will give a scaffold for drug development as well.
Okay, great, thank you. Let me go into the chat room here and see what questions we've got. Some comments. There's a lot of comments about, really enjoying this presentation, excellent information, et cetera, what we've already reiterated. I only see 3. I saw 11 initially in the chat room, but I only see 3 comments here now.
Let me just say that there's no such thing as a silly question. So if you have a question and you want to ask it, please ask it.
Yeah, and it could be about us, about how we're approaching this or anything. I mean, please feel free to really talk and open the dialogue.
Yeah, sure. Yeah, I don't see any other questions here, although there were originally 11 issues posed in the chat room, mostly comments.
Well, Phil, maybe it may give me the possibility of give another reinforcement to the main message here. Here with Dr. Basil, we are forming a spectacular team that is impacting the region, is connecting nationally, and is connecting internationally. We have a remarkable group of scientists that, again, I said their names, and then we have these partnerships that are beginning with you both and with you all. And I think that what it is for us, what is left to us to do is to increase this, to make larger, faster, more. In other words, to reach farther and to one of the things that I want to assure Holly, as you were saying today, that sometimes is you think in some nights that see people think about Kabuki. Actually, Kabuki is becoming extremely well known around the world. And there are numbers of investigators that are studying Kabuki Syndrome right now. And so I think that, that there is by far more hope than there was ever before.
Holly, quite a few comments thanking you for sharing your story. I think it's very important. I mean, as many of you know, Harmony for Hope has over 25 rare storytellers, and we educate medical students, health professionals at a variety of medical schools in the Chicago area, plus at Medical College of Wisconsin. I mean, usually as a medical student, although it's many decades for me now, you know, you get a few minutes here and there on a rare disease, and that's the end of it. You never see a patient with it unless you go into pediatric genetics. So I've read a lot about many of the rare diseases that we represent, however, never have seen a patient until I joined up with this organization, and we have rare storytellers presenting their cases to health professionals and medical students and allied health professional students. So I think it's a great thing to be able to share that information with students and other health professionals.
Thank
Dr.
you.
Urruti, are you aware of what the University of Montpellier is doing in France? I think they're doing some research with Kabuki, with mesenchymal stem cells.
Yes, correct. So there are a few groups that we are trying to reach. Montpellier is one of them. The other one is in Milan, which is a very large group. And we already are working with Barcelona, which is in center for one of the center for Spain, Kabuki, and certainly with people at the NIH and the Mayo Clinic and here. But we continue reaching more. The group of Montpellier is very good, and it has made already contributions to the field, and so it's a respected group. So I really see their work at least once a year or something like that. And I am in communications with them, even though we have not really yet crossed on this. They're esteemed colleagues of ours.
Right.
I'm going to interject here because Trapper's hanging on with us, and he has something special to share. And then I just have a couple, an important message at the end. So I'm going to pass this over to Trapper. He's got something in store for Harrison.
Well,
family.
Thank you, Carrie. I don't think it is anything as beautifully articulated as all of these doctors and scientists today. So thank you so much, everybody, for sharing all of that info, dropping that knowledge on us. I'm going to do one last song here. It's called Walls. It's a song about the highs, the lows, the ups, the downs in life, the duality of life, right? And it, of course, goes out to Harrison. Some days are diamonds, some days are rocks, some doors are open, some roads are blocked, sundowns are golden, then fade away. And if I never do nothing, I'll get you back someday. 'Cause you've got a heart so big that it could crush this town, and I can't hold out forever. Even walls fall down. all around your island. There's a barricade, keeps out the danger, holds in the pain. Sometimes you're happy, sometimes you cry. Half of me is ocean and half of me is sky. 'Cause you've got a heart so big that it could crush this town, and I can't hold out forever. Even walls fall down. Some things are over, some things go on. Part of me you carry, and part of me is gone. 'Cause you've got a heart so big that it could crush this town, and I can't hold out forever. Even walls fall down. Goes out to Harrison. Thank you, Holly, for sharing your story, and to all the doctors and scientists again for sharing all of that knowledge. And I'm so glad that there are all these advancements being made, and all the positivity you're trying to find in all this, Holly, is very inspiring. So thank you, Carrie, for having me, and we'll see y'all soon, hopefully in person later this year or the next one. So thanks again. We'll see y'all soon.
Thank you so much, Trapper. The lyrics to that song are just the best. There's so much heart here today. So thank you. And we just have one last thing to share. We invited the GSPMC Rare Rockstar team to curate a playlist with us in support of our Play This Forward program. And they blew the doors off of it with a really diverse, upbeat playlist, and we're calling it Blinded Me with Science, because it was made by all the scientists at the GSPMC, and we're dedicating that playlist today to the Kabuki Syndrome community. So please go to Spotify and search Harmony for Hope, all one word, lowercase, the number 4, and have a listen to this, because it came from the hearts of our friends at the Medical College of Wisconsin. And I think that this is probably the end of our program. If you're here and you'd like to learn more about our storytellers and the other people in our network, please check us out at harmonyforhope.org. We're always looking for hosts and sponsors of our events. And just thank you to everybody for being here today and working together with such heart.
Thank you so much.
Thank you.
Thank you.
Mary. Thank you, everybody.
Have a wonderful day.
Have a wonderful day. Thank you.